Good evening, everyone from whatever part of the world you're listening into. Welcome to another episode of DYOR podcast show. So this evening I'm joined by Ibra from he'll introduce himself. He's a blockchain enthusiast, and today we just want to talk about consensus mechanism. So yes, please introduce yourself to the listeners, and then we start this conversation going.
Hi guys, my name is Ibrahim Aziz. I am a blockchain enthusiast, as Frank has just said. More to that, I'm a blockchain expert and the founder of the AquaPurge project, which is a regenerative finance project which aims to incentivize people to take action against ocean pollution. So, what this project does is we are building a platform where people can take photos, real-time photos of pollution on the beach. Let's say plastic. You've gone to the beach and seen some plastic or any kind of pollutants. You take a photo through the platform and you get rewarded for it. On our end, what we get is the data of the polluted areas around the world. So we create a good mapping of that, and we provide this data to the beneficiaries, let's say the NGOs, the governments, and all that. And on our own side, we host cleanups, which we also incentivize the people who participate in them. So that's a brief introduction of me, I think.
Wow, that's an amazing work. Just a fun fact: I'm an environmentalist, so big up for whatever you're doing to our only home. And it's amazing you're kind of employing blockchain to do this refi. Yeah, so I guess we'll talk about refi one of these fine days, and I myself am still finding out more about refi, and I think since you have a running project, you will be the perfect person to come and share with us. However, today we want to get a little bit techy, and we want to discuss about consensus mechanism. Just a brief snapshot of what a consensus mechanism is. It's just a protocol that brings all nodes of a distributed blockchain network into agreement on a single dataset. Yeah, and today Ibra will try to demystify all this as we talk about all these amazing tech stuffs in the blockchain ecosystem. So I guess this episode will be pretty amazing for the devs out there, and even people who are looking forward to go deeply into understanding what blockchain is about. Yeah, so Ibra, what is consensus mechanism in a simple way, according to you?
Oh, wanisikia saizi?
Yes, I can hear you.
Okay, so I was talking about, ama nianze tu kama ambao nimekusikia saizi.
Yeah, yeah.
Okay, so I'll give an analogy about
Mm-hmm.
the Byzantine generals problem. So this is a game theory that basically explains consensus mechanisms. So what happens in the Byzantine general problem is that we have four generals that are trying to attack the city. The thing is, for them to actually be successful, they have to attack the city at the same time in such a way that if any of them doesn't do it at the same time, or if there's a bad actor between them that actually retreats instead of attacking, the Byzantines will lose. So This is how consensus mechanism works. They try and solve a transaction. All nodes of a blockchain try and solve the transaction together for it to go across. So with the consensus mechanisms, we have room for a little bit of error. So most of them usually employ at least 2/3 of the nodes to be good actors and to actually validate a transaction, and that is enough.
Okay, so just from a layman's perspective, what we are understanding here is that consensus mechanism is just a way of let me say people agreeing to do something and then they have to do it all at once in the context of the Byzantine theory. Is
Yes,
it
exactly.
is it right? Is my way of understanding right?
Exactly. That's a very good simplification of it.
So, what's the brief relationship between this analogy to now the consensus mechanism?
So,
Because
as you know, the blockchain technology is a distributed ledger technology. So,
yeah.
what this means is that we have a ledger that is stored in more than one device. In this specific instance, we call them nodes. So, for a specific data set to be validated, we actually need the nodes to be in agreement about that particular data set. That's
Mhm.
where the consensus mechanism come in, and that's where you see the Byzantine generals problem coming in as well. So compared to the Byzantine generals, we have the nodes, and we have to have all the nodes in agreement, or at least most of them in some cases, in agreement for a transaction or the data to be validated.
Amazing. So it's like the nodes in this case are just machines like computers.
Exactly. Yeah.
Uh-huh. So they have to agree to whatever has been done so that the transaction can be validated.
Exactly.
Mm-hmm. Um, yeah, I reckon there's so many types of consensus mechanisms that exist in the blockchain ecosystem, and maybe the most known ones that I can also add is the proof of work consensus mechanism. Just from its definition, how it sounds, it just sounds putting in raw energy and being the faster one to solve a certain type of mathematical problem or other equation to prove that you are faster, and then now you have to kind of broadcast or rather report to the solution to the rest of the nodes so that they can agree with you. That is the proof of work uh, mechanism, and I guess it's the one that the Bitcoin technology uses the most, proof of work.
Yes.
Then,
So on proof of work,
mhm,
uh, usually when a transaction is started, let's say started, a nonce is generated. A nonce is a random number that all the nodes inside the blockchain network have to uh, use their processing power to try and find that node. It's a random node, so the computer just tries and generates random numbers until they get the actual number. So this is a process that usually requires a lot of processing power because the nodes can. I mean, you might have to go through like hundreds of thousands of iterations before you actually get the correct nonce. And
mhm.
so that is why we say that proof of work has a huge energy consumption because you need a lot of processing power to actually solve the mathematic puzzle. and especially this gets even more energy consuming as the network grows. Let's say like the Bitcoin network right now, the network is very large. We have so many nodes in the Bitcoin network that it takes you a long time, or let's say not a long time, but a lot of processing power to actually get the nodes.
Wow. So this is why Bitcoin kind of gets expensive sometimes. The network fees.
Yeah.
Okay. And then yeah, even Ethereum used to to use it, the proof of work, and then this one now leads to the other consensus mechanism that I'm coming to. You remember a few, it's almost a year now when there was too much noise about it moving from POW to POS, now the proof of stake. So this is another major consensus mechanism. Now in POS, people just provide their funds, or rather pool their money and hope to get selected randomly to add transactions to the blockchain. Uh,
So on proof of stake,
uh-huh.
uh, validators are chosen based on the amount of cryptocurrency they stake. Staking is a concept in decentralized finance where it acts like savings on a bank. I mean,
Yeah.
you put money into a smart contract in a DeFi, in the DeFi case, and you would be receiving yield. So maybe you'd be receiving 5% yield or 10% yield, something like that. So for proof of stake, uh, yes, you get chosen randomly based on the amount, but then there's also the advantage of being the larger stakeholder in the network. You have a higher chance as a staker with a larger amount than the stakers with less amounts.
So, what do you think POS is a bit efficient than POW? Or
Definitely, it's much more efficient because now you switch from using processing power and now you use your pocket's power.
yeah,
So,
so you move
yeah,
from energy intensive to pocket intensive.
exactly.
So, well, at least you get to save the. I wouldn't really say save the environment, but save some energy.
I mean, when you think about it,
Yeah.
there was a time that crypto started crashing because I think it was Elon Musk who said that it was very dangerous to the environment, and he was right because we had people in China who had warehouses of GPUs mining Bitcoin and
Uh-huh.
actually using that processing power. We know that these devices generate a lot of heat, they generate a lot of fumes, so at some point it had to be regulated because it was also dangerous to the environment as well.
Yeah, and there's a crypto event that I attended for, I guess, Bitcoin miners, and there is also kind of a positive side into the amount of heat generated. So in that meetup, the guy was saying how much you can put that heat into use. Like he was saying, uh, I may not really describe it correctly, but he was saying the heat being generated can be used to power up things like water heating in the homes, where they built something that I think ran over the machines to cool them. So because they're generating so much heat, this one now generated kind of warmed up the water that they were using. Again, some were saying instead of using electricity, they kind of built their own HEP, hydroelectric power, to power these machines. And then after powering the machines, whenever they got heated, they were cooling them again with the waters, and the hot water was being recycled maybe in the homes, And yeah, so people are getting creative out here in as much as it's energy intensive. I think the energy can be harnessed to do some other domestic chores. But anyway, that's not the topic for today.
But
So,
also, when you look at it, I mean, it's still part of the topic.
mhm,
So, one thing that you would see, as especially to one of the reasons why Ethereum moved from proof of work to
work.
proof of stake, when you look at
Mhm,
Bitcoin, Bitcoin has a limited number. So, there's only going to be 21 million Bitcoins ever existing in this world.
yeah.
Is what is being mined. When it comes to Ethereum, Ethereum doesn't work that way. Ethereum's market cap always increases because every time people mine it, it adds to what is already there. So Ethereum's market cap is not capped to a specific number.
To a
And
finite number. Mhm.
yeah, exactly. So if they continued using proof of work, they would have reached a point where they would have scalability issues. That's why they had to switch to proof of stake.
So how is switching from POW to POS solving this issue of more ETH being produced to the circulation?
Hardware and energy costs. That's all that it comes down to.
Okay, so I'm not getting this part where, so how does POS ensure, you see how Bitcoin is finite. So how does POS kind of solves, or rather not solve, but how are more ETH being produced? Because I remember ETH is deflationary. So how is it that POS ensures this goes on?
So uh, it's not really about ensuring it goes on. Rather,
Mm-hmm.
the more you mine, like let's say mining Bitcoin right now and mining Bitcoin 10 years ago, you
Mm-hmm.
need significantly more powerful hardware and
Yeah.
you need significantly more uh, energy to actually to actually mine a Bitcoin right now compared to 10 years ago. Now we are at the final, I think, 3 million Bitcoin, about that area. I remember the last halving was a year or two ago, and we were at around 19 or 18 million Bitcoin mined. I don't know the exact number, but if you look at it like that, I mean, we are very close to the end. It might be many years still, but we are very close to the end. But then with the Ethereum, we are not close to the end because it's not capped. There's no finite number. So the more POW goes on Ethereum, the more people will have to have more powerful hardware, which is a cost, and
Mm-hmm.
even use more energy, which is another cost, which means that it's going to be less feasible for many people to actually mine Ethereum in the coming years. So proof of stake makes much more sense for Ethereum than proof of work.
Mm. Yeah, and fun fact, we are not near finishing mining, at least not in our generation, unless one of us lives up to 2140. So that's when the last Bitcoin will be ever mined, unless someone comes with some alien technology. But yeah, so Bitcoin, the last coin will be mined at in 2140, maybe when we are in our second lives.
Yeah, when I said we are close to the end, I meant in terms of just to clarify, I meant in terms of the number of
Oh yeah,
bitcoins,
oh
not
yeah,
the
in
number
terms
of
of the
years.
number.
We are very far away in the number of years.
Yeah, in terms of number of years, we still have like one,
Hundred, more than
3.4
100
years.
years.
400, yeah, more
Yeah.
than 400. 2140, mark the date. So try to live up to 2140 and you might see the last, you might see history. So there are other types of consensus mechanisms that are not widely used. Um, I've I think Solana uses proof of history. Then there are so many kinds of. Do, can you please also talk about some of these other consensus mechanisms?
So one of the ones that I've come across quite a bit is practical Byzantine fault tolerance. This
Mm-hmm.
is mostly used in permissioned blockchains and enterprise solutions such as Hyperledger. Uh, for this mechanism, it basically the rule of it is that two-thirds need to be proper validators, and a maximum of a third can be bad actors. So this means that if two-thirds of the mechanisms of the nodes agree, then the transaction goes through.
Mm-hmm.
Yeah,
So if we are three in a room, then two of us are good actors and one of us is a bad actor. The transaction will still go through.
exactly. So
So, mhm,
if you just remember a few minutes ago, we talked about the Byzantine generals problem.
yeah.
So now this is a solution to the Byzantine general's problem, or rather, it's a follow-up to the Byzantine general's problem. Now this is Byzantine fault tolerance. I mean, we have the generals. We can still win the battle if more than two-thirds, or at least two-thirds, are good actors, and they actually go ahead and attack as planned. So that's the general idea behind the practical Byzantine fault tolerance consensus mechanism.
Mm.
So
So,
with this consensus mechanism, the general what would we call it? The general idea is that the higher number of nodes that are in the blockchain, the more secure this blockchain is going to be. Because if you think about it, if three people in a room, one person makes a third, but then in 100 people in a room, 33 and a quarter of a person make a third. So
mhm,
it's much harder for there to be 33 bad actors than there is the chance to be one bad actor.
so that's where the Byzantine fault tolerance comes in. So
Exactly.
you've said it's used in mostly enterprise blockchains.
Exactly.
Yeah.
Enterprise and commissioned blockchains, mostly
Because
because it's not really sustainable in large networks such as the public networks like Bitcoin and Ethereum. It's more of controlled. It's more of a controlled kind of consensus mechanism.
yeah, because I think because it has some kind of a loophole, it wouldn't be really good in a very large ecosystem
Yeah, I
that is
mean,
not controlled because of that
yeah,
fault
and
tolerance issue.
the challenge that comes to this is that if someone is trying to attack you, one thing that is common is a Sybil attack. A Sybil attack is where someone would create fake nodes to confuse the network.
Yeah.
So we have 100 nodes. Someone will create maybe 40 fake nodes and confuse the network. So in reality, there's only 100, but then the network sees 140 or 100 and something, and it passes the third of the nodes, and therefore the transaction either fails or they find a loophole and steal some money or something.
So is there like there have been so many hacks in the blockchain space. Is there an example where this has taken place?
Uh, I don't have an example
Uh,
off the top of my head at this moment, but
mhm.
this is one of the common attack on PBFT.
All right. So it's a major. Yeah. I mean, if someone can do that, I'll still go for the Byzantine, where there's no chance, there's no room for any kind of errors. So just another one that I know of is the proof of history. So proof of history is I think it's used in the Solana blockchain. So it's just a historical record that provides the order of events. So I'll use an analogy of like a clock that kind of leaves special mark at every second. So when the different nodes agrees on that mark, they can agree on the order of events. So that's one proof of history. Then there is also the delegated proof of stake. Do you want to take that one?
Okay, so
Delegated proof of stake.
what I know about the delegated proof of stake is that in the proof of stake, the validators themselves are the stakers. In the delegated one, there are people who stake. Those guys who stake now delegate someone to be the validator.
Mhm.
Yeah.
Okay, so the, the the delegators kind of select the validators.
Yeah, exactly. The people who are actually staking their cryptocurrencies, they choose a validator instead of it being themselves. They actually delegate that role to someone
So if we are
or not,
50,
basically.
we
Yeah.
can choose like 15 people to represent us.
Yeah, something like that.
Mm, very nice. There's so many that there's so many consensus mechanisms. There's also proof of elapsed time. This one just requires network participants to prove they have a wait they have waited a random amount of time before they can add a transaction to the blockchain. So the participants can use a trusted execution environment to generate a random waiting period for the node. The node then that waits the shortest amount of time earns the right to add the next block to the chain. And this one is also very ideal for large scale enterprise solutions such as the Intel Hyperledger. And yeah, so this one is a bit complicated, the proof of elapsed time.
Yeah, definitely. I mean, I don't think I heard of proof of elapsed time yet. This is the first time I'm hearing of it. So the
Yeah,
consensus mechanisms are so many.
yeah, there are so
We,
many. Like
yeah,
just like you said, the 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 Byzantine tolerant one is just in small enterprise, not small, but it's kind of
mentioned.
used in enterprises, right?
Yeah, permissioned blockchains. You know,
Permissioned
the
blockchains.
blockchains are divided into I'd say three because we
Mhm.
have the public blockchains like Bitcoin, Ethereum. We have the private blockchains, and we have the permissioned blockchains, which are also sort of the building blocks to enterprise solutions. So that's uh, that's why we say PBFT is applied in permissioned and not the public ones.
Yeah, so even the proof of elapsed time is on the permission where it doesn't require so many like the public to use it because of its complexities. So that's why POS and POW are usually super common because it's straightforward. There's not much complications happening. Uh, maybe we should look at some of the benefits of these consensus mechanisms to now Web3 and the whole of the
Just
blockchain. Yeah.
just before we get to that, I mean, as we've just talked about the three types of blockchains, we
Mhm.
have the private blockchain, which usually utilizes proof of authority. I mean,
The
a private
private
blockchain
blockchains.
is basically a centralized kind of blockchain, which is used, let's say, in the context of a company where you have a CEO. So proof of authority is going to be used, and this is usually used when identity is known. For the other blockchains, identity is not necessary. You just use your private and public keys. For the proof of authority, identity has to be known. So just to add one more to the long list of
Yeah,
consensus mechanism, and to actually complete the list of blockchains and their consensus mechanisms.
yeah, there's so many, there's so many. If we
Mm.
start listing them right now, we might stay here the whole evening just discussing these consensus mechanisms. So I remember before when I read Vitalik's blog now when they were expecting to transition from POW to POS, there was so much hype, just like you said. And now this brings me to the next course of discussion where we would like to understand some of the benefits of these consensus mechanisms.
Okay, so for the benefits, I think each consensus mechanism has its own benefits
Cons,
and cons,
pros
pros
and
and
cons.
cons.
Uh-huh.
So when we start with the first two, we have the proof of work, which is the first consensus mechanism employed by Bitcoin. So with proof of work, it's proven security. I mean, you're going to have to solve that problem, that mathematical problem to be a validator. So it has proven security. But
Mm-hmm.
then the problem it has, the cons that it has, is that it's very energy intensive. It uses a lot of processing power. When it comes to POS, proof of stake, now this becomes, the advantage becomes that this thing is very energy efficient, but not pocket efficient.
Mm-hmm.
And it basically encourages people to hold the token for the blockchain. I mean, you're going to have to hold Ethereum for you to be a validator, which then also helps with reducing the volatility of the price. I mean, less people are selling because they're validators, and validators usually hold a lot of Ethereum.
Yeah, because I remember at one time I wanted to know what it takes to be a validator, and then I saw you have to have 32 ETH and above, and
Yeah,
then
and
it
32 ETH is
crushed
not
my
little
dream
money
of
at
being,
this moment.
yeah,
And I mean, 32 ETH at this moment, how much is that? About
about probably
60,000.
$60,000. Yeah, my dream was shattered when I saw the requirements 32 ETH. So maybe
Yeah,
I'll move to these other smaller blockchains that are starting up that are affordable.
yeah. I don't know about Cardano, but I know that Cardano also uses proof of stake.
Mm-hmm.
We were in Twitter space, I believe, on Monday. That would be yesterday when we're recording this. And the Cardano guys were talking about them being the first blockchain to actually use proof of stake. So maybe we could take a look at how much you would need to to be a validator in
In Cardano,
Cardano.
yeah, because I'm
Yeah.
not yet a whale. So yeah, I'll try and check it out and find out. Yeah, the audience could also try and check out Cardano, or if you are wealthy enough, you can try your hands on it and experience the consensus mechanisms proof of stake. So, so you've touched on the cons and the pros, or there are some other probably stuff that you've left out.
I think for the two, that's the main benefits, I'd say, because
Mm-hmm,
security for POW or proof of work, and
mm-hmm.
energy efficiency and the scalability potential for proof of stake.
Yeah, so it kind of touches on the trilemma of blockchain.
Exactly.
So, well, yeah, the trilemma of blockchain is scalability, decentralization, and security. So POS kind of enhances scalability, and POW enhances
Security.
decentralization and security.
Yeah, exactly.
Mhm. Um, Ibra, what's your take on a person who really doesn't understand consensus mechanism and how it's relating to the blockchains?
So, on this particular issue, I'm going to bring it back to the real world. I think we've seen a lot of people get scammed by people claiming that they're going to do Bitcoin mining with their money and then give them some ridiculous amounts of money. So understanding that how mining works is the first step of actually being a miner, or even actually uh, stopping yourself from being scammed in such a way. Uh, so it's very important, if you're going to be in the blockchain space or in the tech space, to understand consensus mechanisms and how they work, so that you know how mining is done for the cryptocurrency, for the specific blockchains. And yeah, I think that's majorly what my take is.
Mhm. Yeah, and just also my closing thoughts on these mechanisms for achieving consensus are vital to the functions of distributed systems. So, many people believe that the greatest innovation in Bitcoin was the use of proof of work to enable users to agree on a shared set of facts. So these consensus algorithms today underpin not only digital money systems but blockchains, allowing developers to run code across a distributed network. So these are now a cornerstone of blockchain tech and are critical to the long-term viability of various networks in existence. So of all these consensus algorithms, proof of work still remains the dominant offering. An alternative that's more reliable and secure has yet to be proposed. And yeah, there's so much amount of research and development into replacements of proof of work. And just like Ibra said, proof of work is very efficient in ensuring security, whereas proof of stake ensures a lot of scalability and it's very energy efficient, though pocket intensive.
Exactly.
yeah, so yeah, so you mentioned in the beginning of the discussion that you do a lot of DeFi work and you have, should I call it a startup?
More like a social project.
Oh yeah. So please share with the audience your social media handles as well as your social project handles. I'll still drop them in the episode description notes, but you can just share with us.
So you can find me on LinkedIn as Ibrahim Aziz. You can find me on Twitter, Instagram, and all other social medias as Ibraziz21, IBRAZIZ 21. For the AquaPurge project, all our handles are the same: AquaPurge Web 3. AquaPurge Web 3. That's it.
Yeah, I'll drop all of them in the description. Yeah, it's been a wonderful discussion with you, and this doesn't stop here. I guess next time I'll converse with you about refi and other kinds of many topics in the world of blockchain. So yeah, it's a wonderful discussion and goodbye from my side and hope to see you on to the next episode.
Cheers, man. Thank you for hosting me on your podcast.
Yeah, and oh, I forgot to use the famous phrase I usually use. None of this is financial advice, and it's based on our opinions. So that's why you need to do your own research, as the name of the podcast suggests. So do your own research and see you in the next episode.